Assalamualaikum to Sese Zai. Today my friend and I from Group 14 will present our presentation. The title of presentation are fuel requirement, coal, food ultimate analysis, heating value or caloric value. First of all, let me introduce our members. Chow Chi bin, Luqman Adam bin Yahya, Muhammad Ahmad Hakim bin Khaizuran, Nur Aina Amalia binti Faizul, the last one, Zafira Rushdiana Izahanis binti Azizi. The first subtopic is fuels. Fuel is a substance that is burnt to provide nuclear energy, heat or power. There are types of fuels. First, solid fuels. Solid material that combusts to produce energy. Second, liquid fuel, burn to produce mechanical energy and kinetic energy. Third, fuel gas, fuel that are in a gaseous state under normal condition. Fourth, biofuel, it must be derived from biomass. The last one, fossil fuel. These are conventional fuels and non-replenishable. The example of fuels are methanol, an organic chemical, and the simplest acetic alcohol. Biodiesel, fuel derived from living matter called biomass. Natural gas, the main ingredient in natural gas is methane. Gasoline, a hydrocarbon fuel made of hydrocarbon with 1 to 15 carbon atom. Diesel, an energy-dense secondary fuel used to power many heat engines. The last one, hydrogen, a fuel that can be obtained chemically from water or methane.
Assalamualaikum, my name is Muhammad Ahmad Hakim. Before I start part 2, which is fuel requirements, I want to explain about fuel. What is fuel? Fuel can be defined as a combustible substance containing carbon as the major constituent, which gives large amount of heat on burning, which can be used for domestic and industrial purposes. The main sources of fuel are coal and petroleum oil, and etc. During combustion of fuels, the atoms of carbon, hydrogen, and etc. combines with oxygen and liberates heat at a rapid rate. The energy liberated due to the rearrangement of valency electrons in these atoms and result in the formation of carbon dioxide, hydrogen oxide, and etc. The energy released during the combustion process is the difference in the energy of reactants, and that's of product. What are the good characteristics of a good fuel? A good fuel should satisfy the following requirements. First, it should have a high calorific value. Second, it should not produce harmful products like carbon dioxide, sulfur dioxide, hydrogen sulfide. Third, a fuel should have a low content of non-combustible matter. Fourth, ideal fuel should have a higher combustion efficiency. And last but not least, moisture content should be low. Next, I will briefly explain all fuel requirements. Fundamentally, calorific value of fuel determines the quality of fuel. A good fuel should have a high calorific value per unit weight. For example, when used as a fuel, unit of weight of it should develop large amount of heat. Next, it should not produce harmful products like sulfur dioxide, carbon monoxide, carbon dioxide, nitrogen oxides, lead, and particulate matter since they pollute the atmosphere. Moreover, a fuel should have a low content of non-combustible matter in the form of ash, since the presence of ash reduces the heating value and will enhance the cost of storage, handling, and disposal of waste. Then, ideal fuel should have higher combustion efficiency. The lower the combustion efficiency, the less efficient the device is, making it expensive to run, wasteful of fuel, and harmful for the environment. Finally, fuel moisture content should be low so that its heating value should be high. The moisture content it affects the combustion process of the fuel. Thank you for listening. That's all from me.
The subtopic is coal. Coal is a black or brownish-black sedimentary rock that can be burned for fuel and used to generate electricity. There are types of coal: peat, lignite, subbituminous coal, bituminous coal, and anthracite. Stage of coal formation: time pass, pressure increase, temperature increase. We produce peat at the first stage. Second, lignite, or called as brown coal. Third, bituminous and subbituminous. And last, anthracite. For stage 3 and 4, we also call black coal. The vegetation die and form peat. After 5 million years old, peat is compressed between sediment layers to form lignite. After 500 million years old, further compression form bituminous and subbituminous coal. After 1000 million years old, eventually anthracite forms. There are mining of coal. We have two methods. First, underground mining method. Second, surface mining method.
Hello everyone, I'm Chow and I'll continue to talk about coal ultimate analysis. Coal ultimate analysis. It is a more comprehensive analysis compared to approximate analysis. It is a process to determine the elemental composition of coal by percentage mass carbon, hydrogen, nitrogen, sulfur, and oxygen, along with moisture and ash. Why is it important? It is used to evaluate the utility of coal based on the properties of the biomass material. It is also used to determine the amount of oxygen required for efficient combustion. On the right here you can see the equation that shows how all these elements add up to 100% by mass. And down there you can see there is a dry and ash-free equation. If we were to calculate the coal composition without moisture and ash, we can divide the element by 1 minus moisture plus ash over 100. Here, we can see there is an experimental setup to determine the carbon and hydrogen content on coal. 0.2 gram of coal is combusted in pure dry oxygen and then passed through test tubes that contain potassium oxide and calcium chloride. These chemicals are used to absorb the carbon dioxide and water produced during the combustion process. Weight increase in the test tubes are calculated to determine the content of carbon and hydrogen in the coal, with the formulas shown. Next, the content of nitrogen is determined by Jadal method. 1 gram of powdered coal is heated with concentrated sulfuric acid in Jadal flux and then treated with excess potassium hydroxide. With this process, ammonia will be released. This ammonia will then be distilled and absorbed in a known volume of acid. Back titration is used to determine the unused acid by using sodium hydroxide. We then can deduct this amount of unused acid from the original known volume to find the volume of acid used. Then we can use the formula here to determine the amount of nitrogen found in the coal. To determine the sulfur content, the ash of combusted coal is treated with hydrochloric acid. The acid extract is then treated with barium chloride to precipitate the sulfur into barium sulfate. The precipitate is then filtered, washed, and heated to obtain a constant weight, and through the weight we have found, we can apply this formula and we can get the percentage of sulfur in the coal. To determine the moisture, we first dry the coal. And the weight loss from the drying is calculated by subtracting the dried mass from the original mass of coal. We then use this formula to determine the percentage of moisture. Ash is collected and weighted after the combustion process. We then apply this formula to get the percentage of ash. Lastly, the determination of oxygen. As mentioned in the previous slide, oxygen is usually determined by difference. So if we were to find oxygen content, we have to subtract all of the other compositions from 100%. And here shows the formula used to find the percentage of oxygen content. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zafira. I will explain about heating value and caloric value. The heating value may be determined on as received, dry or dry and ash-free acid. It is the heat transfer when the product of a complete combustion of a sample of coal or other fuel are cooled to the initial temperature of air and fuel. It is determined in the standard test in a bomb caloric meter given by ASTM standard D2015. It is defined as the heat liberal in the kilojoule by complete combustion of 1 kg of fuel. For gaseous fuel, the normal practice is to express calorific value in kilojoule per meter square. The heating value of a fuel is the amount of a net release during its combustion. The heat value is a measure of a fuel energy density and is expressed in energy joule per specified amount kilogram. Next, the heating value or calorific value of coal is in the range between 25 to 35 megajoule per kilogram. There are three main types of coal: lignite, bituminous coal and anthracite. Anthracite is the highest coal as it has the highest carbon content, more than 90%, and the highest calorific value. The anthracite coal is the highest quality available because it has the highest carbon content and the fewest impurity, has a shiny surface and has the highest calorific value. Heating value in BTU per pound for liquid fuels are computed using heating value in BTU per gallon. From the heating value in BTU per pound, the heating value in kilocalorie per kg are calculated. We have some exercise in converting unit. A coal with a caloric value of 14,000 BTU per pound has a metric calorific value of 7,782.978 kilocalorie per kg. We just need to multiply with a 0.555927 to get a kilocalorie per kg value. There are two determinations, the higher heating value which is HHV and the lower heating value which is LHV. The difference between the two is given by HHV is the total amount of heat produced when the unit quantity of fuel is completely burned and the product of combustion are cooled to the room temperature which is 25 degrees Celsius, while LHV is the net amount of heat produced when the unit quantity of fuel is completely burned and the product of combustion are not cooled to the room temperature.
The differences between higher heating value and lower heating value. The key difference between higher heating value and lower heating value is that higher heating value can be determined by bringing all the product of combustion back to the original pre-combustion temperature while allowing any produced vapor to condense. So to find lower heating value, we can use formula LHV equals to higher heating value minus 0.09 H, where H is weight percentage of hydrogen times 587. The formula of Dulong type. Dulong type is a formula that used to give approximate higher heating value of anthracite and bituminous coal, which does not include the effect of dissociation. So the formula is higher heating value equals to 1/100 times 8080 times with the mass fraction of carbon plus 34,500 times with the mass fraction of hydrogen minus with the mass fraction of oxygen over 8 plus 22,400 times with the mass fraction of sulfur. Exercise. Calculate the higher and lower heating value in BTU per pound mass using the Dulong type formula of the anthracite coal if the total pressure is 1 atm. So first of all, we can find higher heating value using the Dulong type formula. Given anthracite coal is carbon is 83.9, the mass fraction of hydrogen is 2.9%, the mass fraction of oxygen is 0.7%, the mass fraction of sulfur is 0.7%. And then we insert the given anthracite into the Dulong type formula. Higher heating value equals to 1 over 100 times with 8080 times with 83.9 plus 34,500 times with 2.9 minus 0.7 over 8 plus 22,400 times with 0.7, and then we get higher heating value, which is 7,906.23 kcal per kg, and then we change into BTU per pound. We times with 1.7988, we get 40,221.73. After we get the higher heating value, we can get the lower heating value by using formula higher heating value minus 0.09 times with the mass fraction of hydrogen times with 587, and then we get the value 7,753.03 kcal per kg, and then we change into the BTU per pound. We times with 1.7988, we get 30,946.14 BTU per pound.